I would like to give you my perspective on a more business perspective and what I think in the end of the day about whether delivery drones could be the next big step after drones for surveying and acquiring data. But before I do so, I would like to be very clear with you and tell you how much passionate I am about flying devices so that you can understand my bias. So it started already very young, looking at aircrafts, dreaming about becoming a pilot, maybe to do something good with piloting, being a helicopter pilot to save lives and go in urgent situations, help people with fires and stuff like this, not only showing off with girls. So I tried to become a military pilot in Switzerland, and I had the opportunity to fly very nice aircraft, turboprops, but I got fired towards the end of the process, and that was, I think, a good thing for me, because then I could keep going with my engineering studies, and in the end, do some research about bio-inspired flying devices, taking inspiration from flies and insects, in order to turn those learnings into interesting flying devices that could fly, for example, in cluttered environment, avoid obstacles, avoid hitting people. And finally, create senseFly, which some of you may have heard about, and I will say a few words more in a minute about this. I didn't stop flying since then. I kept flying, for example, aerobatic airplanes, exploring the 3D of the sky. I did some competition at the national level. I also learned landing on skis in a difficult situation. For example, this is landing on glaciers where the performance of aircraft is really limited and where you always have issues with wind, with visibility, with sun, glazing on the ice and stuff like this. And more recently, I started to fly helicopter and also learned to fly helicopters in difficult areas, like landing in the middle of trees, confined areas. And so I know about landing those crafts in situations where you don't have a nice runway, and sometimes it's also very cluttered. But let's go back to mapping drones. So mapping drones, senseFly basically is the company who became the leader in revolutionizing the way surveyors would work. So basically putting drones in the hands of people that didn't want to fly drones at all. They really just wanted to have a better tool to map more efficiently a certain amount of sites. So senseFly, that has been founded back 10 years ago, in 2009, as a spin-off of the Swiss Federal Institute of Technology in Lausanne, quickly became the leader in this fixed-wing autonomous mapping drones. Just to give you a few numbers, if that works, we managed to sell thousands of those EB drones worldwide through a network of 200 points of sales, so it's really a worldwide coverage. And we have also not only points of sales, but points of maintenance, because it's very important to be able to service those people, to make sure that they keep operating with their new mapping device. And all of this at an average selling price of around 20,000 USD. So this make a reasonably successful business in the sense that we could prove profitability after a few years of operation. senseFly, just to give you an idea of the business, of the company's size, is slightly more than 100 employees nowadays, based in Switzerland. And we spend a lot in research and development to prepare for the future, to always keep improving our products. But we also have a department looking after industrialization, supply chain, production, basically assembling the drones, testing them, etc. And we have to take care about marketing, sales, take care of the distribution network. So that's, I think, is one of the rare companies nowadays that have proven profitability in the drone area business, outside of the consumer world. And I'm also quite proud of being able to say that when The Economist draws the map of the world of drones, well, you will find the Chinese. Of course, we all know the multicopters coming from DJI, for example, or Unique. Or on the other side of the spectrum, you will find the big military drones coming out of the United States. And somewhere in the middle of those two extremes, you will find the EB drones from senseFly, which position Europe on the map of drones. So what are mapping drones exactly? Well, basically, it's not about carrying heavy loads, it's just about carrying cameras and flying a little bit like a lone mower in a systematic way over a certain given area. And what really made the difference, back in 10 years ago, there were no possibility to have a drone that would do that by itself. So you would have to learn to pilot those systems. Now, as you have seen today, those systems are fully automatic. So you can put them in the hands of professionals that have no clue about piloting systems, and those systems would just go grab the necessary data. And by taking all of those pictures, you can recognize features on the ground, visual features, from different perspectives. And this allows you to create, after the flight, a 3D map of the site, which is very useful for many people, like surveyors or like mine managers, stock managers. They want to measure volumes. They want to draw the contour lines of the sites, but also people that want to, build new roads, etc. So the drone that we develop is a range of drones, basically, but they look more or less like this. They are smaller than the ones we saw today flying. They are less than 2 kilograms, 1 meter wingspan. Very simple design, 2 wings only, 1 pusher props, and all the necessary electronics, brain, in order to do the flight by itself. So this is just to show you that a very simple device, of course there is a lot of AI inside it, can revolutionize the way people actually grab data. With such a mapping system, you can go really much faster than going in the field, measuring each of the points with a theodolite or with a GPS or with a laser. But I think what is very important in that case, and it's more the business perspective, is that those systems bring a true return on investment to the customers. And we have seen many of those customers that have seen 5 to 4 times time savings on their projects. So by just leaving aside their good old way of measurement and go for drones, they could really spare money in a very fast way. So just to give you an idea, when a surveyor needs to go out to do a data grabbing session, they would ask between maybe $500 to $2,000. So the cost of a drone represents only a small part, but can be significant in that mandate, and therefore the drone can be very easily, can bring a return on investment very easily. So that's very key. And also in agriculture now we see situations, cases where drones can really allow growers to reduce the amount of fertilizers they put in the fields while increasing the yield. So basically gaining money and again finding a quick return on investment on the spending on the drone that will provide the intelligence of the crops. So now the question that some of the organizers asked me to try and answer is delivery drone capable of bringing a sound business case or not? So that's a difficult one, and I think it's very early stage right now. But let me give you my perspective. So of course there are very positive signs out there, and we have discussed that already today, and we'll keep discussing that in the coming days. But there is, I think, more and more of a social acceptance. 10 years ago, when we started with senseFly, drones, we even could not use the word drone because drones were seen as military objects. I think now more and more people are seeing that drones are bringing good impact, and as we discussed, delivering, saving lives, etc. So all of this, and also more and more people have those drones as toys, so they see that they are not really dangerous. So social acceptance is really rising at a fast pace. Also, we hear more and more working groups on rule making for drones, thinking about maybe we should avoid having those drone makers certifying their system as if they were full manned aircraft. And maybe there is a more risk-based approach that could work for drones, because basically drones are less massive, they provoke less risk, and especially if they fly in areas where the density of population is low, like flying over water, for example, then there is no sense of certifying those. And you also have to keep in mind that a drone is not a simple aircraft. If you compare drones to manned aviation, even small ones, drones are more complex because they have autopilots, because they have software, because they have fly-by-wire. All of that is a nightmare if you look at those complex systems from a certification point of view. So applying certification of full man aviation on drones is an economical nonsense, I believe, and also a nonsense in terms of level of risks. And now regulators throughout the planet start to think like this. So there is also a push in electric powertrains. They become more efficient. They are not yet at the level of gasoline engine, but we're coming there. And we have to acknowledge that there is an improvement year over year of something between 3 and 5%, depending on the reports, of battery energy density. So that's a good sign. And the trick also is that electric motors are far more easier to integrate into systems that are innovative. As you have seen a few drones today, you can put several of those engines, you can rotate those, which was not possible in full man aviation, or very difficult. Maybe some of you know about the Osprey and stuff like this. Much more difficult to achieve in the full manned aviations. Autonomy is key, of course. Autonomy means that you can spare the weight of a pilot. Autonomy means that you can operate more safely. And autonomy is also seeing nowadays a very decrease in terms of price. We see now open source systems that cost almost nothing. I'm sure that most of the people demonstrating their drones today are based on some kind of open source software and even hardware architecture. So the cost of an autopilot, the cost of autonomy is really descending at a fast pace and basically replacing efficiently the cost of a pilot wage. Now, how can we ask ourselves the question whether we can do a good business with drone delivery? Well, that's the tough one. So I took, as an example, as a baseline, as a benchmark, if you wish, I took as I call it, the life bank case. So it seems that operating a fleet of motorcycles to deliver important and urgent medicine products cost, all included, wages, everything, infrastructure, costs approximately cost of ownership of the motorcycles and everything, costs something around 50 cents per kilometer. So I think this is a very good benchmark of the cost of transport a drone should be able to achieve or approach, or a flying device, in order to be competitive with such a way of delivering things. So I did my small exercise, and I put this 50 cents for the motorcycle, and of course a motorcycle is not very expensive. And I asked myself, well, if I took a small helicopter to do the job, maybe it would be a nice activity for me now that I'm not anymore CEO of senseFly, and flies those products. Could I be competitive with motorcycles? Well, the answer is no. It would be 10 times more expensive. And this is based, so it would be good because helicopters are faster. You can carry up to, I don't know, 300 kilograms outside the weight of the pilot. But still, the cost of operation would be quite high. And this is based on numbers that you could find in typical helicopter companies. And interesting to note also is $5 per kilometer also includes everything. So the wages, the insurances, the cost of putting the helicopter in a hangar and everything. And this is based on a number of hours of flights per year of 500, which is not typical for a private-owned helicopter, but quite classical in the case of operation of rescue helicopters, for example. Keep just the number in your mind. So then I asked myself, could I do it not with an helicopter, but with a small short takeoff and landing system, a bush flying aircraft, an aircraft that would take off very rapidly, maybe just 60 meters and you're in the air, and an aircraft that has big wheels so that I can land easily on the countryside. Well, the answer is it's still 3 times more expensive than the motorcycle, even though the acquisition price is low. So we have to do it with a drone. Get rid of the pilot, get rid of some of the overheads, and the number would look more or less like that. So I'm sure we heard today about numbers. I'm sure that we can come up with a drone that would cost approximately the price of a big car. So I took 30,000 USD. And at that price, we can certainly not have something that looks like a small helicopter, manned helicopter, but we can certainly aim at that kind of numbers. We also heard about those numbers today. 70 kilometers per hour is really conservative, a reach of 150 kilometers, and payload capacity between 5 to 10 kilograms, but that should be far more than enough for last mile delivery in many cases. Well, I end up on this number of $50 US, all included, of the price per hour. And this is very tough to achieve, in fact. It's far, far less than the helicopter and the manned aircraft. And this makes me think, with some estimation, we can always discuss the numbers, of course, that this drone would have to fly much more than a manned helicopter in order to be able to be profitable. So if you would be there to build a company that would do that, you would have to fly those drones a lot. And when I mean a lot, I mean more than 10 or 12 hours per day, which means that this brings a lot of challenges together with that. And that would be my concluding slide. So of course you need drones that are very reliable, much more than the mapping drones that I discussed before, that would fly maybe once or twice a day, sometimes 10 times a day, but only once per week. So, and every 100 hours, usually you have to do a servicing, a maintenance. And if you fly 5,000 hours per year, you would do maintenance every week. So your system has to be reliable, has to be repairable. You have to be able to make sure that the supply chain is working, that you can have the components in a timely manner. And you also have to make systems that can fly day and night in every weather situation, so wind, rainy, etc., in order to make them really competitive with motorcycles. And of course, all of that wouldn't be possible if you don't have a very strong, so since you need to fly a lot, you can imagine that you will need a lot of drones and in a hub, therefore a high traffic density. And this cannot be possible without unmanned traffic management system, and we'll learn more about this tomorrow, I believe. This is coming. So be able to make sure that those drones are not colliding, be able to dispatch those drones correctly, and communication may also still be an issue. And I'm sure that the Lake Victoria Challenge will help trying to understand at what pace we can tackle those challenges. Thank you for your attention.